Hi, my name is Scott Klein. I'm a technical evangelist for SQL Azure at Microsoft. And today we're going to spend a few minutes talking about SQL Azure, talking about what it is, what you can do with it to give you the understanding that you need for SQL Azure. We'll begin with the basics, talking about how to provision a SQL Azure server and then discuss how to create a database on your SQL Azure server. We'll then talk about how to build and develop applications for SQL Azure and then to deploy your databases from on-premise into SQL Azure. We'll then focus on securing your database, your SQL Azure database, both from within SQL Azure as well as from the application side. And then we'll also explore some of the advanced capabilities around SQL Azure, such as reporting and SQL Azure Data Sync services, and the highly anticipated SQL Azure federations from a scalability standpoint. So with that, let's begin and talk about the basics really about what SQL Azure is. So to understand SQL Azure, you really need to realize that SQL Azure is the SQL Server database technologies that you all know and love, but it's delivered as a service on the Windows Azure platform. This is great because it makes it ideal for both simple and complex applications. We all know and love SQL Server on-premise, so by taking that and providing it as a service on the Windows Azure platform, we get the benefits of the highly scalable solution in the Windows Azure platform, making it ideal for both simple and complex applications. Now, a lot of the benefits around Windows Azure is the high availability. So this makes SQL Azure enterprise ready, being able to support and provide SQL Azure as an enterprise ready platform. The key also is to realize and understand the key word of elasticity, being able to scale on demand. And this is what SQL Azure is, designed to scale and to scale on demand as needed. So the question is, how quickly can I get started with SQL Azure? Well, it's really very simple. Choose a plan, choose a billing option, provision your server, that's it. And at that point, you're ready to get started. You can jump into development and really start working with SQL Azure fairly quickly. So to provision your server is actually quite simple, and we'll see a demo here in a second. But when you provision your server, you're really connecting not to a physical box, but you're connecting through an automatically generated, fully qualified domain name. And so you're given we're used to an on-premise server. We can see it, touch it, smell it. We're used to that physicalness of the SQL Server. But in SQL Azure, we connect through a fully qualified domain name, and that's automatically generated for us. And that server really only contains initially a master database. Now there's several ways we can provision a server, but the real easiest way is to log into the Windows Azure Management Portal, create and provision our servers through there. When we create our SQL Azure server, we specify an admin login credentials, and those credentials really are a lot like SA, the SA login that we know. And then we add the firewall rules and enable the service access. At that point, we're granting access to who can get access to that SQL or to our SQL Azure server. Now we can automate the server provisioning by several methods. One is the Windows Azure Platform PowerShell commandlets. These are freely available, downloaded from MSDN and other locations. But there's also the Windows Azure REST API, management API, that through code we can provision servers and create databases and change firewall rules and things like that. So from a programmatic standpoint, we have great functionality and flexibility to provision and decommission our SQL Azure servers and create databases, or through PowerShell commandlets. So there's a lot of flexibility we have around that as well. So with that, let's stop, jump out, and take a look at how to create and provision a server. So what I'm going to do is I'm going to hop over here to my management portal that I've already got here. And what I'm going to do is I'm going to click on, I've already logged in, and our Windows Azure Management Portal is based on our Windows Live ID, so I've already logged in. And what I'm going to do is I'm going to go down into the navigation pane and select Database. And here you can see that I've got a number of subscriptions already. So we can, if I want to create a new server, I can pick whatever subscription. I can also create a new subscription if I want. Create a new Windows Azure subscription and create my new database, my new SQL Azure server from there. But what I'm going to do is I'm going to go into one of my subscriptions here, and I'm going to create a new server off of that. So I'm going to click Create to create a new server. And the first thing it asks me to do is to select a region in which I want to create my SQL Azure server. Now, right now there's 6: North Central US, South Central US, North Europe, West Europe, and 2 in Asia. Being in Seattle, I'm going to pick the closest one to me, and really, this would probably be North Central US, so I'm going to click North Central US. Click Next. And here it's asking me for the administrator credentials for this server. And again, this is like the SA account. So I'm going to call this SQL Scott and provide a password. And these do, since it is based on the SQL Server, it does utilize the password policies of SQL Server, so I can't type in admin or password or things like that. So there's my administrator login and password. And now what it's asking me to do here is to specify one or more firewall rules to be able to connect to my SQL Azure server. Now you'll notice here there's a checkbox down here that says allow other Windows Azure services to access this server. This is because this is from a security perspective. If I don't check that checkbox, you'll notice when I check that, it adds a Microsoft Services range or rule. This basically says that even if I don't check that checkbox, not even my hosted services within Windows Azure can get access to that SQL Azure server. So if I want my web roles or worker roles or things like that to access to my databases into this server, I need to check that checkbox. I can also add additional rules by clicking Add here and adding another one, but we'll do that a little later. So at this point, I've selected my services. I've entered my credentials and provided a firewall rule, and I can click here and just click Finish. And notice here that it did generate a new SQL Azure server, and we can look to see what the fully qualified domain name is. So there's the server name, but the fully qualified domain name is here. And whenever I access this server, whether it's through an application or through SQL Server Management Studio, this is the server name that I need to provide, the fully qualified domain name. Now I still don't have any firewall rules, so if I tried to connect through SQL Server Management Studio, it would say, hey, you're not coming in through, we don't have an IP address defined for you, so it's going to reject my connection. So I do need to define that, and we'll come back and do that a little later. All right, so this was a simple example on how to provision a server, log into the management portal, provision a SQL Azure server. Oh, let's also create a database on this, and there's several ways we can do this. So here's my server. What I'm going to do is I'm going to go and create a new database, and that's simply by clicking the Create a New Database. And I've got right now, again, it's going to ask me for a name, so I'm going to call this My Test DB. And I have several options. I've got a Web and Business Edition, and right now Web Edition is 1 or 5 gigs. And from a Business Edition, I've got 10 through 50. Now they have announced 150 gig databases. This just hasn't been updated in my portal yet. So I'm going to select just a Web Edition 1 gigabyte and click OK. And there's my database. Now from the portal perspective, that's really all I can do here. I really can't do much more than that. I can test my connectivity, I can go to manage, I can export and import DAC packs and things like that. That's a little beyond the scope of this. We'll talk about that actually a little later for deployment. But I can, through the management portal, I can provision my server, I can create databases, I can drop the database, but I really can't create schema, I can't create tables. But there is an option I can do that through here. So once I select my database, I can go into Manage. And what it does is it opens up a Silverlight portal, another management portal that actually allows me to do this. So I'm going to log in. And it's telling me there's an error connecting to my server, and that's because I have not defined, that's a good point here, I have not defined the firewall rule for this. So we'll actually come back and do that because we haven't defined any firewall rules. So again, you saw that I cannot connect to that. And that was the purpose of this, to say, because I haven't defined anything here, I can't connect to my firewall rule. So we'll actually pull that up and show that a little later. All right, so let's jump back in. So we showed how to provision a server, very simple. It asks you for the login credentials, for the administrator credentials, and the firewall rule. Very simple, and then we created a database. So very simple to get started, and we'll actually go take this a little to the next step a little here shortly. So let's jump back to our presentation. And let's talk about how to work with the databases that we just created. Because it's important now that we've got our SQL Azure database, we certainly want to do something with it, whether we're going to migrate an existing one or do new development on that database. The great thing is that Microsoft really said, you know what, we're not going to make you learn a whole new set of technologies, because you get to use a lot of the familiar technologies that you use today. In fact, since it's SQL Server hosted on the Windows Azure platform, a lot of the Transact SQL support works. So a lot of the T-SQL and Transact SQL language and syntax works in SQL Azure. It also supports a lot of the popular programming language as well. So .NET and ADO.NET, ODBC, Java, PHP, a lot of those popular programming languages you still get to use with very little changes, or if any at all. It does support a lot of the popular frameworks that you use today: OData, Entity Framework, the WCF data services in Hibernate. Again, without any changes, you can now point those to SQL Azure and your SQL Azure database and work with those just as like you would do on-premise. It also supports a lot of the popular tools we use. So again, we can log in through the SQL Server Management Studio, 2008 R2 and later. It also supports a lot of the command line utilities like SQL Command and BCP. Connect right to SQL Azure database, so that's awesome as well. There's also a lot of the modeling tools that you use, like CA and Embarcadero and things like that, also support SQL Azure. So again, there's a lot of support that, again, they're not making you learn a whole new set of languages or a whole new set of tools. What you use today works against SQL Azure. Now, again, let's talk about, there are a few differences between SQL Azure and SQL Server. A lot of the focus between logical and physical administration. When we're dealing with servers on-premise, we have to deal with both the physical and logical administration. We have to worry about patches and upgrades and the physical administration of those boxes, as well as the logical, creating logins and users and permissions and things like that. In the world of SQL Azure, you don't need to worry about the physical administration because Microsoft and the Azure platform takes care of that for you. They are hosting the database platform. So all you have to do is worry about the logical administration of SQL Azure, the logins, the users, the permissions, the schema, the logical aspects of SQL Azure. You don't have to worry about the physical administration, which is great. Now you can focus on really what you want to do, which is do development. Also in SQL Azure, the database and log files are automatically placed. You don't have to worry about where those are, and you can actually get to those, or you have access to the data within a 2-week window, right? So those are automatically taken care of for you. And one of the great things that SQL Azure really does from a high availability standpoint is it provides 3 replicas that are maintained for every single database. So when you create one database, you get that primary plus 2 replicas, and those 3 are always in sync. You don't have to worry about how they're in sync. You don't have to provide the mechanisms for syncing those. Microsoft takes care of that for you. So they're always in sync. And if that primary ever goes down, it routes your connections to a secondary and makes that a primary, and then spins up another 3rd replica for you, and then synchronizes that. So from a high availability standpoint, this is awesome. You get that free for the price of that one database. Now those databases are fully contained, and every table in SQL Azure does require a clustered index, and that's because the mechanism for synchronizing those 3 databases uses those clustered index for performance. So every table does require a clustered index in SQL Azure, and the maximum database size is 150 gigabytes as of recent, as of days ago. So there used to be a 50 gigabyte, as you saw, but the new database size is 150 gigabyte. Now there are some unsupported features, and if you were to take a look at these, some of these really make sense that there aren't there. For example, and because they really pertain to some of the physical administration of SQL Server or SQL Azure. For example, files and file groups and other database placement properties. The SQL Server agent and jobs, like those are not supported in SQL Azure. A lot of the programmatically surface features like Service Broker, CLR, full text search, change tracking, things like that, those are not supported. Hopefully we'll see those very soon, but right now those are not supported. But, again, you've got full relational database capabilities in SQL Azure, tables, views, store procedures, primary keys, foreign keys, indexes, things like that. Now, there are several ways to work with your database and build your database. There's the thin client database development, which allows you through when we went in and provisioned our server, there was that manage button. We went in there. We'll show you that in a little bit. But this is a Silverlight-based portal that actually allows you to work with your database and build your database. It does not have the full capabilities of SQL Server Management Studio, but it is a web-based interface that allows you to do some level of schema creation and management, tables, views, store procedures. It does give you interactive query editing and execution, so you can pick a table and execute queries. You can modify your tables, views, store procedures. So it's a great way to do web-based development and build your database via the web. You can use SQL Server Management Studio as well. So from a rich client database development perspective, there are several ways. There's the SQL Server Management Studio, but Microsoft recently released the SQL Server Data Tools. It's a plug-in to Visual Studio 2010. And this is a Visual Studio IDE for database development. It's a great way to manage and work with your SQL Azure database. Or you can actually take an on-premise database and create a project around that and then deploy that to SQL Azure. You can develop and test in both connected and disconnected states, and the target platform for this really is both SQL Server 2005 and above and SQL Azure. So again, you can take an on-premise database, work with that, provision that, and push that to SQL Azure. And it is free with you can get it free with the web platform installer, with SQL Server 2012 and Visual Studio 2011. Those are all free. But there's also additional download where you can download it from MSDN and work with Visual Studio 2010. Now, there are several ways to deploy your database as well. You can use the Generate Scripts Wizard or a lot of the tools, migration assistant tools up on MSDN for Access or SQL Server or things like that. There are some command-driven options such as BCP, or you can even use SSIS if you want to migrate your data. All those work. But one of the things they're really pushing now is the data tier application framework. This is an alternative to the traditional script-based approach. So instead of going into SQL Server Management Studio and using the Generate Scripts Wizard and scripting your schema and possibly your data, they're saying let's use this alternative and use the data tier application framework. And the whole purpose of this is to dramatically improve your migration and versioning of your databases into SQL Azure. And what it does, if you're familiar with the DAC pack, it provides a single unit of deployment, really just zips things up, puts it into an MSI, install MSI, and you can run that against SQL Azure. Does have support for automatic versioning of database schemas, and supports platform targeting for both SQL Server 2005 and above and SQL Azure. So you can use this to these DAC packs to generate your database installs and run those against SQL Azure. You can build these from scratch or extract from an existing DB. So if you've got an existing on-premise database, you can build your DAC packs off that, or actually from SQL Azure as well. So how do you get the latest DAC? So it does come with the SQL Server data tools that we talked about in the previous slide. It does come with SQL Server 2012 Management Studio, and we saw in the portal there's the SQL Azure import and export service. And if we go back in the portal, we'll show you that. There's the import and export buttons up on the toolbar that allow you to import from a service perspective, allow to export as a DAC or import an existing DAC into and from SQL Azure. There's also the project on CodePlex that allows you to do the same thing. Now, from deploying your database, there really is two approaches. There's an interactive approach for DAC Pack version 1 and version 2. You can manage your server from the SQL Azure Management Portal. This allows you to deploy your DAC Pack or load data through scripts such as bulk copy or SSIS, and these are also supported in the SQL Server 2012 Management Studio. Again, these are great ways to deploy your database. But there's a better interactive approach, what we just talked about on the last slide, which is the ability to upload your backpack to blob storage or from blob storage, so you can log into the Windows Azure Management Portal and import a backpack, which creates your database from there, and also exports an existing database, from SQL Azure to your blob storage. So there's great ways and some flexibilities to how you want to import and export using the DAC packs right from within the SQL Server, SQL Azure Management Portal. Now you can upgrade a DAC pack or a backpack. This is not supported yet in the portals. You need to go through SQL Server 2012 Management Studio for upgrading a DAC pack. So once SQL Server 2012 comes out and is available, you'll be able to upgrade. So, but is not supported yet in the SQL Azure Management Portal. All right, let's talk about securing your database, because there are several ways to do that, both from the database side and the application side, and they're both critical into ensuring that your database is secure. So there really are two ways to secure your database, both from the server side and from within the database itself. So let's talk about those. So right now, SQL Azure does not support integrated authentication. It's just SQL authentication, so SQL Server login name and password. You connect to the master database to create your logins and create and drop databases. This is standard stuff that you do on premise already, so nothing's changed from SQL Azure. The admin login that you created when you provision your server is basically the SA account. The admin login that you created has full rights on the server and all the databases, but best practices states do not use this for within your applications. This should only be used for administration. You certainly can create other users, just like you can on premise, create more logins and users, but do not use the admin login that you created when you provisioned your server for day-to-day operations. It should only be used for administration. You can also manage logins with the create, alter, and drop login commands. Again, this is, if you're familiar with SQL Server, this same thing. But there are some differences between the different server roles. There's the SQL Azure provides within the master database, provides the login manager role and the DB manager role. And membership in the login manager role, server role, grants create, alter, and drop login privileges. So when you create a new user, you can assign them to this server role. There's also the DB manager server role, and membership in this role grants create and drop database privileges. So there really are these two roles: login manager for managing logins, and the DB manager for managing databases. Right. Now there are certainly a lot of benefits around from the security aspect. So logins must have an associated user account to connect to a database. Again, standard SQL Server stuff. If I don't have a login, I can't create. So again, all logins must have an associated user to connect. The admin login is associated automatically with a special user account, DBO. So when you provision your server and you create that main login, this is really associated to the DBO account, and that's what gives you really SA privileges. That DBO has full rights in the database, and really it should only be used for administration. We talked about that in the last slide. Don't use that for anything else. Just use that for administration. Really, this is best practices. Manage your logins and your users the right way. Add users to a system and user-defined database roles to grant privileges via the SP add role member. Organize your database object into schemas and containers for a much granular level of security, and grant privileges to schema containers instead of individual objects for better productivity. So if you need that schema creation capability, use those for better productivity and better level of security. All right, so we just talked about how to do that from the SQL Server, and hopefully you realize that really it's the same, right? I create a login, create a user, and assign those user permissions, whether it's to specific objects or even better to specific schema for better control and better manageability of the security. That was at the database side, but you can also there's also ways to protect and secure your SQL Azure database from the application side. Again, SQL Azure is not really that much different from SQL Server. It does use the TDS protocol, the tabular data stream over TCP/IP. That's supported, so really nothing changes from your application. But the difference here is that SQL Azure only supports SSL connections, so SSL is required. And you do need to set up your firewall rules to be able to connect from outside any Microsoft data center, right? So here's an example of a connection string from an ASP.NET app, right? So the data source is, the entire fully qualified domain name, server.database.windows.net, and then standard, username, password, the initial catalog, initial database. But notice that in the highlighted yellow there that the encrypt equals true. You must have that in your connection string to be able to connect because only secure SSL connections are supported to connect to SQL Azure. So again, the fully qualified domain name for connecting, for the server name, and then encrypt equals true in your connection string. And this will help ensure a secure connection between your application and SQL Azure. Now, again, special considerations from the login. If you have a legacy application, or some providers may require a special format for the login. In other words, it's going to be login at server. So if you create a new login, it'll be like SQL Scott at, and when it says server, it's not the fully qualified domain name. It'll be that the server name in brackets there on the left and highlighted in yellow. So like SQL Scott at, the randomly generated 10 characters. So you may have to pass that as a login. But some best practices, things to keep in mind as you're working with SQL Azure. There are some things that SQL Azure is doing in the back end to make sure, since this is a hosted environment, that everybody's really playing nice and that you're not taking critical resources from somebody else who happens to have their database on the same box as you. So, for example, idle connections will be terminated after 30 minutes. So manage your connections wisely. Use connection pooling. Don't just throw a bunch of connections out there and leave them idle. Those take critical resources. So if SQL Azure sees idle connections, it'll kill them after 30 minutes. Long-running transactions will be terminated after 24 hours. Again, we want to make sure that you're not taking critical resources from somebody else. So if you've got a runaway transaction or you've just got a long-running transaction and it's still going after 24 hours, it will be terminated. There are some denial of service guards that will terminate suspect connections with no error message. So if SQL Azure determines that, hey, something funky is going on, it will terminate those connections as well. Failover events will terminate connections as well. So if it has to fail over, all the connections will be terminated. SQL Azure does some throttling on the back end. It wants to make sure that, again, you're not robbing critical resources from other individuals. So what it will do is it may throttle your work, may throttle your connection, which means it may scale back or actually terminate your connection depending on what it deems as too much. So it will do some throttling. So best practices state use connection pooling and implement retry logic to handle transient failures. This is a best practice. This should be done anyway, right? Always use connection pooling. And now that we're going over the internet, you possibly may have your application on-premise connecting to a SQL Azure. Regardless of whether your application is on-premise or in being hosted as a hosted service in Windows Azure, implement retry logic. This is just the best practices wherever the application is. That way, if a connection drops or is terminated, you can handle that termination gracefully, right? Now, latency is introduced for updates due to high availability replicas, so there will be some latency. You want to make sure you handle that. Now, we're not talking high latency, but there will be some latency. You might want to make sure that you handle those. Now, there is no support for distributed transactions, and we'll talk shortly about the scalability of SQL Azure federations. But there is no support for distributed transactions. So if you want a distributed transaction, kind of a homegrown scenario, really what you need to do is build query the result sets, grab those from the databases, and then combine the results of those queries within the application tier. So now we will talk about SQL Azure Federation, and other ways to get scalability. But from a distributed transaction standpoint, right, if you've got distributed queries, if you want to, that needs to be handled within the application. So you execute queries, grab the result sets from the different database, and then combine those within the application. Okay, so let's take a look at some of the advanced capabilities of SQL Azure, such as reporting, SQL Azure Data Sync services, and SQL Azure Federation. SQL Azure Reporting Services has been out for just a little bit. This is great, very welcomed. So let's take a look at some of these and dive into what these capabilities really provide. So SQL Azure is continually expanding. Features and enhancements are continually being added. Quarterly service updates are always added. Versus on-premise, the on-premise databases, on-premise SQL Server, you see a release every 18 to 36 months. Microsoft is very serious about SQL Azure, so it's improved engineering efficiencies. Much more frequent updates, almost quarterly updates. This is really to push and get the functionality and services that you need out to you as quickly as possible. There are several powerful new services out there. You can, for example, from the Windows Azure Marketplace, you can buy and sell finished data sets on the Marketplace. You can visualize data with SQL Azure Reporting. We talked about this a few minutes ago. You can synchronize data with SQL Azure Data Sync, and then SQL Azure Federation's ability to partition and scale out your data to multiple nodes. So there's a bunch of new services out there. SQL Azure Data Sync and SQL Azure Reporting were recently released from CTP and are now in production. This is awesome because now it's right there in the management portal. We'll see that in a little bit. SQL Azure Federations is finally out. Thank goodness, because this is a great way from a scalability to improve your performance, SQL Azure performance in the cloud. Now there are new developer opportunities, again from devices connected to continuously available cloud services. This is through things like OData and other services being able to work in a connected and disconnected state. There are some consumer applications and SaaS applications. A lot of ways from developer experiences and developer environments, many opportunities to work with SQL Azure and the SQL Azure platform. So we talked about SQL Azure Reporting, one of the new features. Let's dive into that really quick. So SQL Azure Reporting really is SQL Server reporting services, but served as a service within the Windows Azure platform. It's ideal for operational reporting against SQL Azure data. It is enterprise ready with automatic support for high availability, so you can scale your Azure reporting servers easily and quickly within the SQL Azure platform. It is designed just like the benefits of SQL Azure, right? Designed to scale on demand. If you need more servers, scale those out. It works great. This is SQL Azure reporting services. You can get started very, very quickly by going into the SQL Server Management Portal and just provision your report server. At that point, it's just you've got a report server just like you would on premise, and you just deploy your reports to there. Very easy to get started. And authoring reports really does not change. You open up bids, author reports, and the only difference is now instead of publishing your reports to an on-premise report server, you're publishing those to a SQL Azure report server. So you can build your reports with the report designer, deploy your reports to the report server. It's great because really nothing changes from what you do on a day-to-day basis for authoring reports. You're just now publishing those to the SQL Azure report server instead of the SQL Server report server. Rendering reports with Visual Studio Report Viewer controls is the same. You're just pointing the reports to the report server instead of on-premise. So again, great flexibility and functionality there. And visualizing your data for your reports is really just as easy. So I can use the Visual Studio Report Designer, report definition language. I can report items and visualizations, report server web services and URL access, Visual Studio Report Viewer control. So there's many ways that I can point and get access to my report data. Same way. Again, nothing changes from what you're used to on premise. Now you're just saying I'm hosting my server, my SQL Azure service, my reporting services in the cloud, and pointing my tools and technologies to SQL Azure. Now, there are some differences between SQL Azure and SQL Server reporting services. Again, as we talked about earlier, there is no support for integrated authentication, so your reports must use SQL Azure or SQL authentication. An admin user configured, again, your administrator, an admin user is created and provisioned upon provisioning your report server. That admin user has all the rights on the server, and again, should be used for administration only. Now, don't confuse this with the SQL Azure server. When you provision a SQL Azure report server, again, there'll be another box for you to create credentials for that reporting server. This is different than your SQL Azure server. Okay. You can add users to the appropriate items, such as a browser and publisher and server roles. Again, from a security perspective, and you can grant item level permissions to folders and reports, just like you can on premise. You can grant these item level permissions to say it's to this folder or specific report. So you can get to that level of granularity in SQL Azure reporting services. Now let's talk about some of the differences and comparisons to reporting services. Again, just like SQL Azure, you're focusing on the logical versus the physical. In SQL Azure reporting services, you're really focusing on the logical and not having to administer the report server itself. You're focusing on just the logical aspect of reporting services. The report catalog and temporary database are automatically provisioned for you. Again, you don't have to worry about that. This is part of the logical and physical administration. The Windows Azure Management Portal does now replace the Report Manager. So again, you've got now one place to go do everything. You don't have to go to multiple portals to administer your SQL Azure and your SQL Azure Report Server. SSL is required again. So now that we're talking SQL Azure, SSL is required. And one of the key things here is that the SQL Azure, from a reporting perspective, SQL Azure is the only data source available right now for reports in SQL Azure reporting services. So you can't use managed code or other types of objects for your data sources right now. The SQL Azure specific database is the only data source available for SQL Azure reporting services. Now there are some unsupported features, and there's just a few. For example, there's no report builder, no subscriptions, no scheduling, no caching yet, no custom extensions. Again, we can't. Again, SQL Azure is the only data source available, so there's no custom extensions there. No report models, and no external images. So again, you've got some limitations when you're using SQL Azure reporting services, but they're working on those. Hopefully, we'll see those soon. But again, it is SQL Server Reporting Services hosted as a service. Few limitations, but still you get that great functionality. You don't have to worry about the physical administration of reporting services, but now focus just on the logical administration, just developing and authoring your reports and publishing those, and while still getting the great benefits of the Azure platform, scalability, high availability. All right, so with that, let's move on and talk about SQL Azure Data Sync Services. This is the Sync framework. If you're familiar with the Microsoft Sync framework, this is the Sync framework technology, but along with everything else delivered as a service on the Windows Azure platform. And it's ideal for scheduling synchronization between data sets hosted in SQL Azure or SQL Server. So it doesn't really matter where your data sets are, whether you want to synchronize between SQL Azure and SQL Azure or SQL Azure and SQL Server. It's a great way to synchronize your data, and the great thing is no code. You can do all this in a very great wizard-driven interface. So it does use a hub and spoke topology. So in other words, you've got a hub, and so it allows you to synchronize multiple databases at the same time. So some special considerations here. It does handle conflict resolution between hub and client, so you can specify who wins. The sync direction is configured between each client and the hub, so you can say, is this to hub or from hub, or is it bidirectional? So you specify which direction the synchronization is going. The sync schedule must be between 5 minutes and 1 month, so nothing less than 5 minutes, nothing greater than 1 month. But you get some great flexibility there as to what your sync schedule looks like. The data sets must include multiple tables and can be filtered, and triggers are added to data set tables. So uh, you can specify multiple tables, and then actually go down to the column level is to say, what you want to synchronize. Tables are added to the hub and client schemas. So if you're familiar with the sync framework, it does add additional tables for the tables that you want to synchronize to manage the synchronization. Now, if you're doing also SQL Azure to SQL Server, if you're going to synchronize between on-premise and SQL Azure, it does require that an agent is installed on-premise for every client that you want to synchronize on-premise. So you don't need to do that in SQL Azure, but if you're synchronizing SQL Azure to on-premise SQL Server, every on-premise SQL Server must have an agent installed in order to synchronize. Now, I mentioned this earlier. The great thing about the SQL Azure Data Sync services is it is completely wizard driven. If you've ever used the sync framework, you know that there's a lot of code that you have to write to get the synchronization to happen and manage all the conflicts and things like that. This is not the case with SQL Azure Data Sync services. It is completely wizard driven and done right within the management portal. And you can set up synchronization just within a matter of minutes. It is so slick. So you can deploy database to hubs and clients. You can set the synchronization schedule, set the conflict resolution policy, define your data sets. You can add SQL Azure clients to the topology. Again, anything, if you're synchronizing on-premise, you need an agent on the client to be able to add them to the topology. And then you deploy that topology, and then voila, you're ready to go. So really, within just a matter of minutes, we can set up a synchronization between SQL Azure and on-premise SQL Server, all within just this great wizard-driven interface through the management portal. Now, there are some operational considerations because you can do manual synchronizations. That is supported. Hub updates require one synchronization to distribute to all the clients. So really, what they're saying is, have a plan when you set up your synchronization. Client updates require 2 synchronizations to distribute to all clients. And the sync framework, because it's based on the sync framework, this may the sync framework triggers may affect application behavior. So, again, if you're using this, and again, this is built on the sync framework. Depending on how you have this set up, this may have an effect on your application. So just be careful as you set this up what effects this may have. So nothing big, but just kind of an FYI. All right, so with that, let's stop and take a look at what I'm going to do is demonstrate how to synchronize between SQL Azure and SQL Server. So let's take a look. All right, so what I'm going to do is I'm going to jump out here back to my portal, right there, and I'm select the data sync node. And once I've selected data sync node, it's going to ask me, all right, what subscription do I want to set up SQL Azure Data Sync services with? So I'm going to pick my SQL Scott Azure subscription, and I'm going to say right now I have no sync server provision, so I'm going to click Provision Sync Server, agree to the terms, click Next. Obviously, it's already got the subscription picked for me. Click Next. And now, what region do you want to set up your synchronization, your data sync services? And right now, I've got several options. I've got North Central U.S. and West Europe. So I'm going to pick North Central U.S. and click Finish. And notice that it is provisioning. And now that it's provisioned, now notice that I have the North Central U.S. and sync groups and member databases ready to go. So I haven't provisioned anything from a sync group perspective yet. I've just provisioned my sync server. Now at this point, it's actually pretty easy. We've got several steps in order to set things up. So what I'm going to do now is I can say, go up here and say, well, I want to create a new sync group. But so I've several ways to set this up. But what I'm going to do for this demo is I'm going to click this here, sync between on-premise and SQL Azure database. So I'm going to click that, and what it does is it says, okay, give me a sync group name. So I'm going to call this my test sync, and then click Next. And if I scroll down here, it's going to say, well, let's add a SQL Server database to the sync group. So I'm going to click that. and it's going to say, well, okay, let's add a SQL Server to the sync group. And I could either select from an existing sync member database, but because I haven't installed anything yet, what I need to do is I need to add a SQL Server database to the sync group. I am going to make this bidirectional. I'm going to click Next. And at this point it says, hey, you want to synchronize between on-premise and the cloud. So what we need to do is, I don't have the agent installed yet, so I'm going to install a new agent. Otherwise, if I had installed it, I could click the other option, through an existing agent, but I have no existing agent yet, so I need to click and install a new agent. Click Next. And then it says, all right, let's download this agent. So I'm going to click Download. And it's going to take me out to the portal and say, all right, let's download this. So what I need to do is I need to click Download. And what I want to click here is, since I'm running IE9, I want to select Run. So Next. I agree. Next. Now this says, what's my username, and what do I want to, what account do I want to run the agent? Because what it is it does install an agent. So it says, what do I want to install this with? So account with network access. So I'm going to put my my password in here, my account that has admin. So I'm going to say Redmond Scott KL, and then my password. All right, click Next. Where do you want to install it? So I'm going to click Next and Next. All right, click Yes here. Perfect. Click Close. All done, so I can close this window. But what I need to do now is I need to go, and what it did is install the Microsoft SQL Azure Data Sync Agent Preview. So I need to start that. Click Yes. And what I need to do here first is I need to actually enter a key in order to be able to provision and register my local agent, right? So what I need to do is I need to go get a key. So I'm going to go back here and let's go get a key. So I'm going to enter, the next step is I need to specify the agent name. So I'm actually going to call this test sync. Okay, and then I'm going to generate a key. So generated a key, and when I need to copy that to the clipboard. So yes, let's make sure it copies. Go back to my agent and enter the key. Enter the key here. So paste that. Click OK. Great, I'm done. So what I'm going to do is I'm going to register a new server local here. So I'm going to say register, and I'm going to use Windows authentication. The server is local. I'm just going to call this local. And the database I'm going to sync, I've got a database out here already on premise, is called Northwind 2. I've already got a Northwind and a Northwind 2, but what I want to do is Northwind is has populated, and I've actually synchronized that to Azure. But what I want to do is synchronize my Azure back down to this Northwind 2 database, because there is no data in here. So let's select top 1,000 rows. No data in my Northwind 2. So I'm going to synchronize my Northwind 2 database. I'm going to say Northwind 2. All right, test connection. Let's try that again. There you go. So I'm not going to enable SSL. So connection succeeded. Save that. And there we go. So can I ping the service? Yep. So now I'm communicating between on-premise and SQL Azure. So my synchronization is already done. All right. So I can close this. I'm going to actually minimize this. And I'm going to click Next. All right. So I'm going to get a list of get a list of databases. And there's my Northwind 2. So notice that because the synchronization, the agent is communicating with the synchronization service in Azure, I already picked my database here, and I can click Finish. Okay. So notice now that step two, I provisioned, as it says, not yet deployed, right? Because I haven't done anything yet. But now it's asking me in step 3, let's provision a SQL Azure database. So I'm going to pick a SQL Azure database here, and my server name is, I'm actually going to go back to, let's go back here because my server is here, this server, just to make it easy. There. What I need to do is I need to provision the username, and I'm going to enter the database name, Northwind. Okay, let's test that. Connection successful. Click Add. All right, so now I have my, notice down here I've got my on-premise database. I then have my cloud database, and I can actually add more if I wanted to. Notice I can add a second on-premise or a second cloud database, but I don't want to do that. But step 4 says, now let's set the sync schedule and conflict resolution policy, right? So I'm going to just set this for every 30 minutes, and my resolution policy is the hub wins, okay? Now notice here that, and we'll come back and see this, notice here that my SQL Azure database is defined as the hub, okay? Not the on-premise, but my cloud database is defined. You may not be able to see that, but we'll look at that in a second. All right. Now it says, let's look at what is the data set that you want to synchronize. So I'm going to click edit data set, and it's saying, all right, well, what tables do you want to synchronize? Okay. So we're going to synchronize. Let's select all of them, because we can say, you know, for every database, for every table, what columns do you really want to synchronize? Okay, so we're going to synchronize all of those, and we're going to click OK. So, and we can get to a very granular, right? So not just from a table level, but to a column level. I want to synchronize all of these, and we can actually filter. Hey, we can specify a filter to say only filter these rows if we want to. For example, if we select orders, you know, we could apply a filter that says, okay, only filter where order ID is between whatever, right? So we can get very granular as to what we can filter. So I'm going to click OK here because I'm going to do all tables and all columns, and click OK. All right, so at this point I'm done. All I need to do is click Deploy to save changes. Okay, so I'm going to click Deploy, and what it's doing is it's actually creating, one or more tables have a circular foreign reference. Okay, and I think, so we're actually going to go back and let's edit our data set. And I think that's because the Northwind, one of these tables has a circular reference. And I think it is employees. Yep, employees. All right, so we're not going to do, we'll have to go back. Let's fix that. We're not going to do all the data set. So let's select none. And let's actually just synchronize customers. Should be okay with customers. All right. We'll just do customers for this example. We'll click OK. And now let's deploy. So we're just going to do customers and synchronize that one. So it says provisioning. Now you notice that it says synchronizing. So it is actually synchronizing between on the SQL Azure and on-premise. So when it's all done, we should be able to go back into our on-premise and see some data synchronized, at least the customer table back down in SQL Azure, or on-premise, sorry. So we'll wait a minute. As soon as it's done, we'll go take a look. All right, it says it's good. Now there wasn't a whole lot of data in the table, so let's go back into our database, and we'll go to the Northwind 2. And notice, let's refresh our tables here. And notice that it did put some synchronization tables for customer in our database. But we can go to our customers and let's look at the data. Select top 1,000 rows. And there we go, 91 rows. So it did synchronize those. Okay, there was nothing in there before. Now it just synchronized those. And it, for 91 rows, it didn't take very long. But let's go back and let's make a change to our on-premise. And let's go back to our database here. Let's create a new query for Northwind 2, and let's change. Let's take a look here. Select star from what do we take? Customers. So we're going to change the company name from Around the Horn to Around the Horn 2. So I'm going to say update customers, set company name equal to, let's just copy this, Around the Horn 2, where customer ID equals, we're going to actually take that. Okay. Now let's also go back. We also need to connect here. We need to connect to our SQL Azure database. So let's go connect to that just to show. So we're going to connect to that. Okay, and let's go to our Northwind database and create a connection to that. Star from customers. So notice that it says Around the Horn, but we want to update Around the Horn to Around the Horn 2. Okay, and notice that there's now not just one row affected, but 2 rows affected, because this was the update to the customer table, but it also inserted a row into our tracking table to say we made a change here, so that the next time the synchronization changes or kicks off, it knows that, hey, here's a change, we need to synchronize that change. So not just one change, but 2. So let's go back and let's look at this. So all right, it does say Around the Horn 2. Let's go back to our portal now, and let's do a quick sync, a manual sync. So synchronizing. They both say synchronizing. That's good, right? So let's go back to our, not that. Let's go back to our database, and let's actually query this database now, because this is our local database. We made the change. We made the change on premise, and we want to make sure that our cloud now has that change. And sure enough, there's the change. Right, so very simply what we did in this demonstration is we simply illustrated how to set up SQL Azure Data Sync services to synchronize between SQL Azure and on-premise SQL. And really very, very simply. So imagine doing that with the sync framework. Right, this only took a matter of minutes to set up synchronization. All right, so very simple and very effective. All right, let's go back to our demo. All right. So let's move on and talk about scaling out our data. So from one of the great features that we just came out is what's called SQL Azure Federation Services, and this provides the ability to true scale out at the database level. Integrated database sharding that can be scaled to hundreds of nodes. So if we've got one database and we're really trying to scale that, we can then take that and scale that out to really hundreds of nodes to get true scale out. And the whole purpose of this was to simplify multi-tenancy via flexible repartitioning. How can we take a database and repartition that to get true multi-tenancy? We can do this online through online partitioning operations, which brings elasticity to the data tier and does not require downtime. So the whole goal is that I can repartition to multiple nodes without any database downtime. Happens behind the scenes very quickly, all said and done, and I still get that, and I get that scale out without taking the database down. Now, with this robust model, development and administration of complex scale-out system is greatly simplified, and there are ways to do that through the Windows Azure SQL Azure Management Portal. So again, the concept is I've got the federation root. I've got my multi-tenants, and then I could scale that out into as many nodes as I want to get that true scale out. So let's actually stop and take a look on how this is set up. And what I'm going to do is I'm going to bring in Jihan. I have Jihan introduce himself to walk through the example on how to use SQL Azure federations. So let's jump into a demo real quick. Now, before we do that, special considerations. A logical database can contain multiple federations to scale out parts of our schema. We don't have to do all of it, but whatever parts we want to scale out. Now, and the applications express the partitioning scheme through the federation key. So the whole concept here is that what I'm going to say, what do I want to federate on? And that value becomes the federation key. So I'm going to say I'm going to federate on customer ID. That customer ID then becomes the federation key for all the partitioning that we want to do. Well, so we've reached the end. We thank you for your time. Here we've talked about just a quick introduction to help you understand everything, not everything, but a lot of things about SQL Azure, both from partitioning a server and creating a database to security and building and deploying your database, to a lot of the cool features and functionality from reporting services to SQL Azure Data Sync services to SQL Azure Federation. So thank you for your time. We'll see you next time.